Hello and welcome back to Adrian's Chemistry Laboratory. We're still continuing on the theme of sulphur. As you can see, I've got my yellow waistcoat to celebrate yellow chemistry. And we're going to show three different methods of producing sulphuric acid. Now just to remind you, I did say if we can get up to 2,000 subscribers, so please do tell your friends, we will be celebrating by opening up this tin of oleum and doing some very interesting and slightly dangerous experiments with concentrated sulphuric acid known as oleum. So please do tell your friends and like and subscribe. Today we're going to do a couple of experiments. The first one's in the fume cupboard, and it originates around 1750s by a chap called Valentino, who began manufacturing sulphuric acid, believe it or not, by burning niter, as in potassium nitrate, mixed with sulphur. I've got some flowers of sulphur here, with a very, very small amount of antimony trisulfide. That was really just to help the mixture. So he basically was burning a much simplified version of gunpowder. Now imagine getting up out of your bed every day to do that and say, what have I to do today? I have to go and mix some highly flammable materials together and set fire to it, and the products are going to make concentrated sulphuric acid. And I have here, just in this mortar and pestle, the same mixture of potassium nitrate, sulphur, and a very small amount of antimony sulfide. Now later on it was discovered that the antimony sulfide contaminated the sulphuric acid, and about 1770s it wasn't used any longer. So I'm going to put a small amount of this mixture into the bell jar, and we're going to later on test it to see if there's sulphuric acid. So if my assistant joins me over in the fume cupboard there, I'm just going to take the bell jar away from this little pneumatic trough, and all I've got is a small quantity of water in the bottom of the pneumatic trough, and I'm going to add just a very small quantity because it's quite a vigorous reaction of this mixture of potassium nitrate, sulphur and antimony trisulfide. And there's an excess of potassium nitrate to form nitrous vapors, which you can see actually I've got. This is 100% concentrated nitric acid here, and I don't know whether we're able to see it, but it certainly will be. You can see the vapors come off that. So you can see the nitrous vapors coming off that very, very dangerous substance. You should be having gloves, of course, even to look at that. So what we're going to do is we're going to ignite this, and then I'm going to cover it with the bell jar and then allow the gases to absorb into the water, and later on we'll test it for sulphuric acid. So here it goes. This is somebody's job that they used to do every day. So we have a nice, not overly vigorous reaction there. I'll just close this down. And you can see already the slightly brownish yellow vapors, and that's from the nitrogen dioxide and nitrous oxides, which would then oxidize the sulfur dioxide, which would then dissolve into the water to actually form not sulphurous acid but sulphuric acid. So we need to leave that for a couple of hours till it totally absorbs, and we'll come back and test it later. So there's our leftover residue. It's cooled down enough to handle. It's just a residue of the melt, and then that's just a little piece of iron block to hold it up out of the water. And what we're going to do now is just some very basic analysis to see whether we've got some sulphuric acid here. So I'm just pipetting a small amount into some test tubes, and we're going to do some very basic analysis. First of all, we're going to see if we actually have an acid formed here, and I'm using a little bottle there of BDH universal indicator. Of course, I shouldn't be ever pipetting it out of the bottle. That's very, very bad practice in case it gets contaminated. So we're just putting in it, and you can see it's clearly going red. So it's going from a greenish colour, which is neutral, into a very red colour, showing that we do have an acid here. So our next test is to see whether we've got a sulphate. And if we add some barium chloride to our test tube and then add some of the suspected sulphuric acid, we should get a very dense white precipitate of barium sulphate. It's a standard test for sulphates. And yes, very, very clear reaction there. Nice white dense precipitate, showing that we more than likely have a sulphate. And if I add a little of the sulphuric acid to the test tube with the indicator into it, and then add some of the barium chloride, we'll get a sort of a milkshake sort of colour. Again, just confirming that we do have a very dense precipitate of a sulphate. Then the next test is simply going to see whether we get an acid reaction with some magnesium. So I'm pipetting it into the test tube, and then we're going to take some magnesium turnings. These are magnesium turnings that you would normally use for Grignard reactions, but a nice surface area on them, and we'll be able to see if there's any fizzing reaction. We should get hydrogen released if it is indeed a strong acid. So in they go, and immediately get a very vigorous evolution of gas. So we do get an acid and metal reaction there. And the last very basic test is just adding some sodium hydrogen carbonate solution, and we should get some effervescence of carbon dioxide. Again, we could test all these gases, but I'm fairly sure it's sulphuric acid. So we'll see if we get a bit of a evolution of gas here. Oh yes, quite clearly. Yep, we get some fizzing, showing that indeed we are releasing carbon dioxide from the sodium hydrogen carbonate solution. So that should conclude that we do indeed have sulphuric acid. So the next step would be to reduce the acid down to a more concentrated level. And here I'm just taking a large porcelain evaporating basin and I'm adding some of the dilute sulphuric acid to it, and then we're going to heat it up over a period of time and evaporate off as much water as we possibly can and concentrate it. You can clearly see here in the bottom of the evaporating basin is a brown viscous liquid, and that is the equivalent of concentrated sulphuric acid, and we're just going to put it into a much smaller evaporating basin so that we can reduce it down even further. Clearly see here white fumes, and I'm very glad I've got the fume cupboard working, very choking fumes of sulphuric acid vapour, mainly sulphur trioxide vapour coming off as it's getting concentrated. And one very simple way to see whether we've got concentrated sulphuric acid is to see whether it's going to dehydrate this piece of tissue, and you can see immediately that the tissue is destroyed and turned into carbon. And just in case there are still any further flat earthers out there and don't believe that this is concentrated sulphuric acid, I'm going to pour it over some chicken meat and we'll see again what happens. It just shows you how dangerous hot concentrated sulphuric acid can be to your skin, and you can see here that the small piece of chicken is immediately charred and is dissolving away into basically a precipitate of pure carbon, which is what would happen to your skin if you were careless or unlucky enough to get some concentrated sulphuric acid onto your skin. So again, it's just highlighting the dangers of concentrated sulphuric acid. Investigating the origins of the manufacture of concentrated sulphuric acid from the element sulphur. And I have here a lovely setup that actually it was taken from a very old book called Bloxham's Inorganic and Organic Chemistry. And it's a very similar setup to this setup here. And this is what's called the lead chamber process of making sulphuric acid. Now, industry has long moved beyond that and now use platinum-based catalysts to manufacture sulphur trioxide. This is a lovely illustration from one of my father's 1950s chemistry books called A School Chemistry for Today, showing the contact process. We're just cutting through to show you an experiment that I did several years ago in my small laboratory in my house, and it shows the oxidation of sulphur with oxygen, and then as it passes through a platinum catalyst here, which is platinized asbestos, and goes into this flask, we're producing clouds of sulphur trioxide. And here's another lovely illustration from the same book showing not the contact process, but the lead chamber process, which I'm going to demonstrate now in the laboratory. So in this setup here, what we've got is a simulation of what's called the lead chamber process. And I'm hoping to get what's called Nordhausen crystals developing in this flask. And in this flask, we've got oxygen being delivered and just generating that through hydrogen peroxide and manganese dioxide. In this flask, we've got concentrated nitric acid. And in our steam generator then, it's going to be producing steam as it's doing now and dripping into our flask. And in the lead chamber process of making sulphuric acid, all these components would come together. And we've forgotten our most important one, which would have been sulphur. And that would have been burnt in the form of either large blocks, but more than likely it would have been iron pyrites. So we're just going to set fire to our sulphur here. It's burning away, and what's happening is the sulphur dioxide is getting sucked up through our little thistle funnel, in through the nitric acid, and then into our lead chamber. We should begin to see something interesting happen. I don't know if you can just see, it's certainly gone brown. We're getting an oxidation, and look, we're getting, yes, it's going nice and cloudy, because what's actually happening is that we're getting sulphur trioxide and sulphur oxides. I'm just going to take off the steam right now. Now we've got the motor in. And if we were really lucky, and I've tried several times to get little crystals forming here. I've done it once before, and they hiss whenever the water hits them. And that would dissolve to form sulphuric acid, and that would have been the liqueur then would have been further dissolved in other concentrated sulphuric acid to get a higher strength. So all we're seeing here is simply a very small version of what's called the lead chamber process. And so that puts the sulphuric acid back on the shelf. I hope you enjoyed those experiments showing 3 different methods of how to make sulphuric acid, and please like and subscribe.